This is Mrs. Wainwright's math class, chapters 6, 7, and 8, Pkt E Review Sheet Solutions. Test review for numbers 6 through 10 on the review sheet. Question number 6 says, Mrs. Castellano has given 965,231 compliments to students so far this year. If Mrs. Castellano gives 1,000 more compliments, which digit in the number will change? As we do with any word problem, we go back to the question mark and back up to the asking word. Question mark is after change, and the asking word is which. So the question says which digit in the number would change. It wants to know which digit, so we need which single digit would change. Well, let's see what we know. We know that she has given 965,231 compliments. That's the starting number. We know that it says she's going to give 1,000 more compliments. So if I start with 965,231 and I add 1,000 to it, which digit would change? There's two ways in which you could solve this problem. We'll show you both right here. First, take the number itself and write it down, which is 965,231. Now, I know I'm adding 1,000 more to that. So if I added 1,000 to that, which digit would change? Well, that would be the digit in the 1,000s column. So I could go through my place value chart places to see which column is the 1,000s column. Well, the 1 is in the ones column, the 3 is in the tens, the 2 is in the hundreds, and the 5 is in the thousands column. The thousands column is the same as the 1,000s column. So the 5 is the digit that would change. Or, as we've showed you earlier this year, another way you can do it, I think it's the way that I like better, is I write down the number, 965,231. If she's giving 1,000 more compliments, I'd be adding 1,000 to that. So I put the 1,000 underneath it. It's like an addition problem. I don't have to solve the problem, I just have to figure out which digit would change. And if I said 1 plus 0, the 1's not going to change, it's going to stay the same. 3 plus 0, still going to stay the same. 2 plus 0, still going to stay the same. But if I say 5 plus 1, the 5 is the digit that would change. So for this answer, which digit in the number would change? The answer is 5, or the digit 5. Let's take a look at number 7. Point K is shown on the number line below. I see this number line and I see K there. Which number sentence best describes the value represented by point K? And I see that all of my multiple choices are either that point K is greater than something, less than something, or equal to something. The only way I'm going to be able to figure this out correctly and accurately is to figure out the value for each tick mark on this number line. So the first thing I do is look at my starting point. My starting point is 0 and 1/10, or 0.1. My ending point is 0 and 2/10, or 0.2. Let's see how many tick marks there are between 0.1 and 0.2. Normally I would just count with my finger, but above each tick mark I'm going to put a very faint red dot so you can see where I'm counting since you can't see my finger. So from 0.1 to the next tick line, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 tick lines on this line between 0.1 and 0.2. Well, if I want to space these out, I can change my 0.1 into 0.10 and my 0.2 into 0.20. All I did here was add an extra digit, a place value 0, to the hundreds place. But I can then count up from there, and I can change each digit in the hundreds place, and that should help me to label my number line. So let's see how I do that. It's very hard to label a number line writing from left to right, so I usually turn it sideways so that my numbers don't go from one tick mark into the next tick mark. So I start with 0.10. Well, what would come next? 0.11. And the tick mark after that would be 0.12. The tick mark after that, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, and the final one that's there is 0.20. So I can tell that, yes, I did number this correctly, 0.10, 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, 0.20. It does work out. The next thing I need to do is focus on the point K, which is given to me. I'm going to take a nice blue line and put it straight down through point K. And here's my point K right here. So let's look at this. Point K is someplace between 0.12 and 0.13. Now remember from science when we talked about that, if it's halfway between one and the other, we could just tack a 5 onto the end. So technically, point K is at 0.125. Something good to know if we ever needed to write exactly the number that it was at. But let's go ahead and look at the choices that I have here. Choice A says K is greater than 0.13. Let me find 0.13 on my number line. Here it is, I'll underline it in green. Is K greater than 0.13? Well, if it was greater than it would have to be to the right of it. And K is not to the right of it, K is to the left of it. So no, K is not greater than 0.13, so it can't be choice A. Let's take a look at choice B. Choice B says K is less than 0.13. Is point K less than 0.13? Well, again, look up at our 0.13. We underlined it in green. Is K less than that? Yes, because when it's less, it's to the left of it. So yes, that is a correct statement. K is less than 0.13. So my correct answer choice here will definitely be choice B. But since we don't know what our answer choices or our number line will look like on our test, let's go ahead and look at choices C and D to understand why they are not the correct answers. Choice C says K is equal to 0.15, which means that K would have to be exactly at 0.15 because equal means it's exactly the same. So let's find 0.15. I'm going to use an orange marker to find it. There it is. Is K at that point? No, it's not, so it cannot be equal to it. Therefore, C is no good. Letter D says K equals 0.35. Let's go to look at our number line and find 0.35. Wait, 0.35? That's not even on my number line. My number line goes from 0.10 to 0.20. 0.35 isn't even on there. So, if it's not even on this number line, but K is on the number line, then K could not possibly be equal to 0.35. So my one and only one correct answer here is choice B. Let's take a look at number 8. This actually should be a fairly simple problem, but a lot of you have been getting these wrong on tests, so make sure you study this one so that you don't get it wrong. Number 8 says, which number is 1,000th of 6,320,574? So let's break it down. Which number is 1,000th of this number? Well, remember back to earlier in the year, that word of is a very special word. If of comes after a decimal or a fraction, it's the mature way or the big kid way to say multiplication. And of does come after a decimal or fraction because 1,000th is less than 1, so therefore it is a decimal or a fraction. So of means multiplication. Well, 1,000th. I can write 1,000th as 1 over 1,000. That's 1,000th. That's the fraction form. Or I can write 1,000th as a decimal form, which would be 0, because there's no whole numbers, decimal, 0, which is in the tenths column, 0, which is in the hundredths column, and then a 1, which is in the thousandths column. So it would be 0.001 is the decimal way to write 1,000th. And whether I choose to use the fraction or the decimal, I should be able to see this and say, oh, that's a base 10 number. Remember, we've been doing base 10 numbers every single chapter since chapter 1 in September. So at this point in time, we should be able to focus on that and say, oh, that's a base 10 number. Well, when I see a base 10 number and it's multiplication, I go the way that I've always learned it. 1,000th, is that greater than 1 or less than 1? Well, 1,000th is less than 1, so I'm going to put an L. Less means left, which is going in that direction. How many places will I have to move my decimal to the left? Well, that depends upon the number of zeros. In the fraction 1 over 1,000, there are 3 zeros, and in the decimal 0 and 1,000, there are also 3 zeros. So how many places do I have to move that decimal to the left? 1, 2, 3. That's right, I have to move it 3 places. So I'm going to take my number, write it down without commas, because remember, once I move my decimal, my commas will no longer be in the right place. So I'm going to write down the given number, which is 6, 3, 2, 0, 5, 7, 4. I have to move my decimal 3 places to the left, but there is no decimal. Again, I learned how to do this back in September. I removed the invisibility cloak, and anytime I remove the invisibility cloak, the decimal is all the way at the very end of the number. There it is. Cross it out, and I'm going to move it 1, 2, 3 places to the left. Remember to cut properly in line and put that decimal right there. I'm then going to write this number on my answer line, which is 6, 3, 2, 0, decimal, 5, 7, 4. And exactly how I said it is how I write it to make sure I put the decimal in the correct place. I do it 1 digit at a time and the decimal as I get to it. Now, for my final answer, if I'm not 100% sure of where to put a comma, on a graded item I would not put it in. But we always like to practice when it's not a graded item. So when we practice putting a comma in, we start our comma at our decimal and move 3 places to the left. So we see the decimal, it's going to move 1 place past the 0, another place past the 2, another place past the 3. So my comma is going to go right there, which is 6,320 and 574 thousandths. That's the final answer for number 8. All right, let's take a look at number 9. Lara is making homemade hot chocolate. Yum. She placed a Hershey bar in the pot and then poured in half a cup of milk. Wait, hold on right there. How did she make hot chocolate? She put a Hershey bar in the pot and then added milk. Oh my gosh, I need to try this. As soon as I'm done making this video, this is the hot chocolate I'm making. It sounds to me like my favorite hot chocolate that I'll ever have. All right, so let me backtrack. Lara was making hot chocolate. She placed a Hershey bar in the pot and then poured half a cup of milk. After tasting it, she decided to pour in 3/5 of a cup more milk. What was the total amount of milk Lara added to her homemade hot chocolate? Anytime I have a word problem, I find the question mark and go back to the asking word. So the question that I need to answer is, what is the total amount of milk that she added to her hot chocolate? I need to know how much milk she added. First of all, it's asking for what's the total amount. When I want a total, it's either going to be an addition problem, if it's 2 different numbers being added together, or it's going to be a multiplication problem if it's the same number that's added together over and over and over again. So let's see what I have. I know that she first poured in 1/2 a cup of milk. Then she tasted it and decided to pour in 3/5 cup more milk. Did she take 1/2 cup and pour in 1/2 cup over and over and over again? No. First she poured in 1/2 of a cup, then she poured in 3/5 of a cup. So I know that this has to be an addition problem because it's 2 different numbers. Next, I'll take my numbers and add them. So I have 1/2 plus 3/5. When I get ready to add them and I say, oh, when I add fractions, I have to have common denominators. My denominators are 2 and 5. Those are not common. So I'll need to find the least common multiple or least common denominator of 2 and 5 to make equivalent fractions with common denominators. So I'm going to find my LCD here. Remember, it's fastest if you start with your largest number. So I'll say 5 and 2. I'm going to go through my 5 times tables. First I say 5. When I go through my 2 times tables, do I say 5? Nope. After 5 comes 10. When I go through my 2 times tables, do I say 10? 2, 4, 6, 8, 10. Yes, I do. So as soon as I get to the yes, that's my least common denominator. That's going to be the new common denominator of both fractions. So I'm going to put a fraction bar with the new denominator of 10, a fraction bar with the new denominator of 10. This is where I got the 10 from the least common denominator. What am I going to do next? I'm going to make a window box next to each fraction. And for the top one, I say 2 times what equals 10? Well, 2 times 5 equals 10. Whatever I put on the bottom of the window box, I must put on the top. So if I said times 5 on the bottom, I have to say times 5 on the top. And now I solve. 1 times 5 is 5. So 1/2 turned into 5/10. Okay, let's move down to the bottom fraction. Put my window box, and I say 5 times what equals 10? Well, 5 times 2 equals 10. So whatever I put on the bottom of the window box, I must put on the top of the window box. So I'll say times 2. And I'll solve. 3 times 2 equals 6. So 3/5 turned into 6/10. Now I have two fractions with common denominators, and I can go ahead and add them. Denominators need to be the same because they're going to stay the same. And 5 plus 6 is 11. My denominator that stays the same is 10. So I have 11/10. Now, as we learned for this chapter, anytime I have an answer with a fraction, there's two questions I need to ask myself. First question, is it a proper fraction? Meaning, will it work in a chicken fight? Is 11/10 a proper fraction? Will it work in a chicken fight? No, because 11 is larger than 10. So what happens when it's not a proper fraction or it won't work in a chicken fight? Boom. We drop it right down into the division box pool and cross it out on top because that chicken fight team just is not going to work. So we're going to go ahead and divide here. So my brother or sister has 10 of my favorite snack. I have 1. Am I happy? No. I have 11. Am I happy? Yes, I am. So this is going to be a single digit answer. 10 goes into 11 one time. 1 times 10 is 10. Subtract. Remember, you have to do something when you have a remainder. You can't just ignore it. Keep seeing that on tests over and over and over again. You either have to make it as a remainder or a fraction or a decimal, but something. You don't just ignore remainders. Since I'm working with fractions, we know that means my remainder has to turn into a fraction. So my remainder becomes the numerator. My divisor, the number outside the box, becomes my denominator. I have 1 and 1/10. Now there's no whole number to add this to. I always have to check that because if I was adding mixed numbers, I'd have to add that to whatever whole number sum I had. But there isn't, it's just fractions. So 1 and 1/10 looks good, but now I have to ask myself question number 2. Is the fraction fully simplified? Well, the fraction portion is 1/10, and if there's a 1, my fraction is done. So yes, it's fully simplified. The question says, what's the total amount of milk Lara added to her homemade hot chocolate? And the answer would be 1 and 1/10 cups is my unit when I look back into my problem. So 1 and 1/10 cups of milk. And that's my final answer. Notice how I wrote my mixed number. The whole number is the same size as the fraction. So it most certainly does not look like 11/10. It most certainly does not look like 1 over 110. It definitely looks like a mixed number, the whole number being 1 and the fraction being 1/10. Please be careful about that when writing mixed numbers. Okay, and the last one for this section is number 10. The question says, find the value of the equation. Do not simplify the answer. That's interesting. Do not simplify the answer. Remember, the first assignment we had was to watch the video that told us 2 questions when your answer has a fraction in it. In order to be considered correct, number 1, you need to make sure that it is a proper fraction and that it will work in a chicken fight. And number 2, you need to make sure that it's fully simplified unless the directions tell you differently. Notice here, the directions tell you differently. They tell you do not simplify the answer. Therefore, because it says so, we will not be simplifying. Okay, so this is an addition problem with 3 fractions. Let's write them vertically. I have 3/8 plus 1/5 plus 2/4. Put my addition sign because I have to have an operation to get partial credit and my equal bar. Now, when I add fractions, I have to have common denominators. My denominators here are 8, 5, and 4. They are not common. So I'm going to need to find the least common denominator and make equivalent fractions with common denominators. So I'll set myself up for scrap paper for my LCD. Fastest way to do it, we learned, is to start with their largest number. So I have 8, then 5, and then 4. I go through my 8 times tables. The first thing I say is 8. When I go through my 5 times tables, do I say 8? No. So don't even bother checking the 4. What comes after 8 in the multiples? 16. When I go through my 5 times tables, do I say 16? No. Don't bother with the 4. 8, 16, 24 comes next. When I go through my 5 times tables, do I say 24? No, it can't be divisible because it doesn't end in a 0 or a 5. So that's no for 5. Don't bother with the 4. 8, 16, 24, 32. When I go through my 5s, do I say 32? Nope. So don't bother with the 4. 8, 16, 24, 32, 40. When I go through my 5s, do I say 40? Yes. 40 is divisible by 5 because it ends in a 0. Now I have to check the 4. When I go through my 4 times tables, do I say 40? Well, yes, because 4 times 10 is 40. So when there's 3 or more numbers, as soon as everything is yes, that's your least common denominator. So I'm going to make new equivalent fractions, and they will all have a denominator of 40. So fraction bar with a 40, fraction bar next to this one with a 40, a fraction bar next to this one with a 40. Let me set myself up with all of my window boxes, and now I can figure out what my new common fractions will be. Let's look at the top fraction, 3/8. What do I do to the 8 to turn it into a 40? Well, 8 times 5 is 40. Whatever I do on the bottom of a window box, I must do on the top of the window box. So I'll say times 5, and then I'll work it out. What's 3 times 5? 15. So 3/8 turned into 15/40. Okay, let's go down and look at our second fraction, 1/5. What do I do to a 5 to turn it into 40? Well, 5 times 8 equals 40. Whatever I do on the bottom, I must do on the top. So I'm going to say times 8 and solve. 1 times 8 equals 8. So 1/5 turned into 8/40. Let's take a look at my bottom fraction, 2/4. What do I do to a 4 to turn it into a 40? Well, 4 times 10 equals 40. Whatever I do on the bottom, I must do on the top. So 2 times 10 equals 20. Now I have 3 fractions with common denominators, so I can go ahead and add them. My denominators have to be the same because they're going to stay the same, so my denominator will stay as 40, and now I have to add my numerators. Since there's more than 2, I'm going to kind of cross out in my ones column as I go. So 5 plus 8 equals 13, plus 0 still equals 13, so I'm going to put down the 3 and carry the 1 up here above that 15. And 1 plus 1 equals 2, plus another 2 equals 4. So I have 43/40. Normally I would want to say, oh, that needs to be simplified. But remember right up in the top, it says, do not simplify the answer. Remember those 2 questions that I asked myself are both actually parts of simplifying. So turning an improper fraction into a proper fraction is one way to simplify, and then using the GCF is another way to simplify. So I'm just going to leave my final answer as 43/40 because the directions say do not simplify the answer. Therefore, that's the final answer for number 10.